Here we have a buried pipeline a cathodic protection impressed current ground bed, a copper sulfate electrode, an oscilloscope, a microammeter, a recording voltmeter connected through to a data logger, and the oscilloscope trace is being shown on this screen and recorded in this computer. We have a transformer rectifier with settings for voltage and amperage. The charges go from the transformer rectifier through this microammeter to the ground bed. They then disperse throughout the damp cloth that represents the ground, and they return to the transformer rectifier through connections at this drain point to the negative of the transformer rectifier, at the same time passing through coating faults on this buried pipeline. This is measuring the pipe to soil potential differences between the contact point here in the electrolyte and the negative connection, which is to the pipeline metal itself. This meter is set on milliamps and is showing the switching from 0 to 0.22 milliamps, which is the current going through the ground bed. This experiment is to show that when the switching on and off, we cannot see the polarized potential either on the curve shown by the oscilloscope or by the recording of the data logger. You can see that when it switches on, there is 1.994 volts. When it's off, there is 0.90, a moment, 0.927 and going lower. I have set it so that it is on for 3 seconds and off for 1.5 seconds. But we can set this to any period of on and off, and we still do not see the kick which we are supposed to see as the polarized potential of the pipeline metal. When you have more than one coating fault, you have more than one corrosion cell, and therefore you cannot measure the polarised potential against any sort of reference. This reference is the reaction between the copper wire and the saturated solution of copper sulfate. It is not a reference because wherever you move it, the readings are different. I'm going to move it, and you will see that the measurements have changed. That hopefully proves that the on-off potential is not capable of measuring the polarised potential of the pipe.